Hello everyone, this is the sixth video of chemical kinetics, and in this video we are going to discuss about Arrhenius equation. Arrhenius equation is the relation between rate constant and activation energy and temperature in Kelvin. So this is the Arrhenius equation, that is K is equal to A e to the power minus EA upon RT, where K is the, what is K here? K is the rate constant, EA is what? Activation energy. Now you can say here activation energy, R is the gas constant and T is the temperature in Kelvin, where A is the frequency factor and gives the frequency of binary collision of reactant molecule per second per liter. Generally this equation, Arrhenius equation, is directly asked in short questions, but if you will take the log form of this, log base E K is equal to log base EA minus EA upon RT. Log base E will be converted into 2.303 log base 10. Then what will happen? 2.303 log base 10 K is equal to 2.303 log base 10 A minus EA upon RT. If you want to take the common 2.303 R and it will be cancelled 2.303, then what will be? Log base 10 K is equal to, it will be cancelled and it will come log base 10 A minus EA upon 2.303 RT. So this equation will be used in the numerical. So this is the log form of Arrhenius equation, but this equation will be used for the numericals purpose. And if the question will be asked what is Arrhenius equation or what is the relation between rate constant and temperature in Kelvin, then you can write only this equation. But with this equation you must write the meaning of abrasive. What does it mean? K, R, E, A, T and A, right? We know that if the temperature is changed, then rate constant also get changed. Temperature is the only factor that affect both rate as well as rate constant of the reaction. Now if we will take the differential form, then what will happen? Log base 10 K1 minus log base 10 K2, or we can say K2 upon K2 minus K1 is equal to, what will happen? What is the formula? EA upon 2.303 R, it will be common, and inside the bracket 1 upon T1 minus 1 upon T2. If you will solve, you will write K1 here, then it will be T1. If you write K2 here, it will be T2, and you will write K2 minus K1. Then you will get this equation. So this equation will also used for the numerical purpose if two rate constants are given at different temperature. In that case we can use this equation. Please take the screenshot of this. Now by the graphical method we can also calculate the activation energy. If we will plot between log base 10 K and 1 by T, what will happen? You will get straight line, is it? And how the slope will be calculated? Now in the last slide we have calculated this equation from the Arrhenius equation after taking log. Then we can write in this manner also, log base 10k is equal to minus EA upon 2.303 R into 1 by T plus log base 10 A. Then it is equal to y-axis it is m x plus c. So this is the y-axis, log base 10k, m is the slope and x is 1 by t. Then what will be the slope? Slope will be minus EA upon 2.303 R. Is it okay? Now if we will take log base E and 1 by t, then 2.303 will not be there and the remaining thing will be same. So now the slope that you can calculate by this way also, is it? So generally we are getting the question under in the graphical method also, when the graph is plotted between log base 10k and 1 by t and slope will be asked, or in the slope is given, R is given to you and activation energy can be the question. Is it okay? Please take the screenshot of this also. Now one more topic we can we have in this chapter, chemical kinetics, that is mechanism of the reaction. So what is mechanism of the reaction? The study of the steps involved by which the reaction takes place. Now in reaction we are directly watching that reactant and product, but under mechanism we can see how reactant convert into the product and what are the steps involved. So now see that the reaction is NO2 plus CO gives NO plus carbon dioxide. So nitrogen dioxide react with carbon monoxide, it gives nitric oxide and carbon dioxide. Now this reaction occurs in two steps. First, NO2 combined with another NO2, it form NO and NO3. NO3 is intermediate, it combined with CO and form CO2 and NO2, right? So if you will add these two steps, what will you get? 2 NO2, NO3 cancel, NO2 once this side and one this side, right? It will be cancelled. So you will get NO2, CO, NO, CO2. So now if you will see the first step, NO2 combined with NO2 and it is a slow step. So you know very well that rate is directly proportional to the concentration of reactant, active mass of reactant, they are taking part in slow step. Is it? So now how many reactant of NO2 taking part in slow step? That is 2. So you will take the power 2. So by that way we can also calculate the order of reaction. So what is the order of reaction? The order of reaction will be 2. If we want to consider carbon monoxide also, because it is also a reactant, so carbon monoxide is not taking part in slow step, so its power will be 0. Carbon monoxide is taking part in fast step, so its power will be 0. Then 2 plus 0 will be equal to 2. So if you will see the reactant, you will find that only one NO2, but here the power is what? 2. That can be explained on the basis of the mechanism. So with the help of mechanism, we can also calculate the order of reaction if we know the slow and fast step. On that basis we can calculate the order of reaction. Right? Now take the screenshot of this also.